Grasslands are not real. Now, that is a bit misleading, but there's not really any way to title the video without giving an entire dissertation within that video title. So what I'm trying to say is, let me explain. Grasslands make up roughly 40% of the landmass on Earth, depending on who you ask. There are a number of different grassland types: meadow, steppe, savanna, or tall grass prairie, short grass prairie, mixed grass prairie, shrub steppe, annual grassland, desert grassland, high mountain grassland, so on and so forth. This is misleading because grasslands as a biome do not exist. Grass, of course, is real, but grasslands are not really a thing. At best, you can say they are placeholders, and at worst, they are artificial placeholders. There's not a consensus on how to organize grasslands, and that is largely due to how we categorize biomes. A biome is essentially classified based on two things: vegetation and climate. However, in the case of grasslands, they range from growing in tundra to desert to tropic and swampy climates. Basically, wherever grass grows in, there is already a type of biome in that same place. Before we continue, we need to talk about a symposium where this idea was formulated. A man by the name of William L. Thomas had an idea in the 1950s to arrange a summit consisting of geographers, historians, biologists, and anthropologists from all over the world to discuss the topic of man's role in changing the face of the earth. The concept was to get as many experts together to work on a concise argument and evidence for the human effects on environment and geography. William Thomas enlisted Carl Sauer to lead the symposium. Sauer was an influential geographer at the time, but someone who has been largely ignored despite his expertise in the field. What the symposium produced was a volume with essays from everyone who participated, laying out what has been deemed the first large-scale evaluation of what has happened and what is happening to the Earth under man's impress. They delivered what should be one of the most important texts on man's impact on the Earth, but unfortunately it wasn't received very well and was all but forgotten by mainstream science and environmental studies. Humans refusing to accept responsibility for their actions is probably the reason for this symposium's lackluster response. All of the members of the symposium are interesting in their own respect, and considering they were in a post-World War II time, the ability to bring people from all over the world is impressive and significant. But like I said, it wasn't taken seriously, which must have been very frustrating for Carl Sauer, as he was extremely critical of man's damage to the Earth. That aside, there are very thought-provoking topics ranging from the earliest humans to modern industrialization on the subject of humans' relationship with ecosystems. I will probably reference various essays for videos in the future, but what we are going to focus on today is one written by Omer Stewart. He's an anthropologist who advocated for native tribe land claims and their free use of hallucinogenic cactus peyote. The chapter is called Fire as the First Great Force Employed by Man. Diving right into it, grassland appearance is commensurate with human expansion, meaning grasslands weren't a thing until humans and early human ancestors started populating the continents, specifically when humans learned how to make fires. The timeline of grasslands is about 5 million years ago. Although evidence is scarce for other primates using fire, it's likely that this was going on to some extent. There have been some proposals that Australopithecus used fire. These are the hominid species of the famous Lucy skeleton. They lived in the late Pliocene and early Pleistocene periods, so about 4 to 1 million years ago. There's not really any reason to assume Australopithecus didn't use fire, other than it's not the conventional theory, which in the scientific and historical community means they absolutely never used fire. But that's not really important, since only in the last 1 million years did grasslands start to expand in earnest, and arguably in the last 100,000 years or so do we see grasslands closer to the sizes of the ones we have today. Evidence for our more immediate biological ancestors using fire goes back over 1 million years. The timing does work out in that regard. So, what did humans use fire for? The main uses for fire outside of as a hearth was for hunting, herding, and later planting. Before humans had weapons like spears and bows, they used fires to clear predators and open up the difficult terrain of a forest in order to scavenge food from the aftermath and to hunt prey. It's an effective method, but one that is uncontrollable in total damage to a forest. Fires were also set to herd larger animals to desired locations. It also created more space for larger herbivores to graze as grass replaced trees, meaning humans could set up feeding grounds, ensuring they had access to food and meat. When tools were invented, especially with forge fires, humans cleared forests in order to farm and build houses with their new tools, a practice we have not stopped doing. Studies in Aboriginal and native hunting techniques confirms that humans regularly cleared forests with fires in order to hunt, herd, traverse, and farm. These traditions and practices are thousands of years old, and it is safe to assume they are tens of thousands of years older than that. Detailed knowledge seems to have been built, probably over many generations, of how and what to burn. Certain trees have roots that can be ignited for weeks after a fire dies out. This gives them a window to start fires for other purposes and grants access to traveling far, knowing that you have a fire ready to start. The origins of fire use is as mysterious as the origins of humans. Venturing into colder climates and traveling away from caves for days at a time meant that humans needed to make campfires on their hunting trips or journeys. The thought of a fire dying on you was not worth the risk, especially if you had to backtrack at some point. They built fires to last and kept them burning long after they departed the campfire. It was safer to risk a wildfire than to lose your campfire. The first forest fires from humans were probably accidental, a result of leaving campfires burning unattended. Once a forest burned, all the other consequences could have been observed. Less predators, more food, more herbivores eating grass, open space to travel through. Seasonal burnings allowed humans to manipulate the environment to their advantage, and eventually as a tactic in war called scorched earth. From ancient Rome to America, burning territory was always a brutal strategy. Carl Sauer, in a different essay, coined a term that I liked called fire economy. Ancient humans, he said, could be considered to have used fire economies as a way to generalize how they obtained their resources, which was almost exclusively with fire. Hunting, gathering, cooking, warmth, defense from predators, light in darkness, creating tools, all of it revolved around the control of fire. Understanding how widespread these fire economies were, we can start to see how humans shaped the geography of the world. Humans have been burning forests for 1 million years. It is hard to imagine that not having an impact on the environment and the earth as a whole. Human fire use is just one part of the essay. Things get really fascinating from the botanical perspective. All of these ideas would probably not have existed if not for this simple observation, that the grass in grasslands can always be found in and at the edges of any nearby forests. Put simply, there is no evolutionary grass species that isn't also a ground cover for forests. Any prairie, steppe, or savanna grassland hasn't reached what's called climax vegetation. Climax vegetation is the point at which a particular species of plant dominates and can reproduce in equilibrium with an ecosystem. Climax vegetation gives way to a biome, a set and steady environment. Though the idea of climax vegetation is somewhat flawed in definition due to the constant evolution of life, it can be employed to accurately describe contemporary ecosystems. So, why are grasslands not climax vegetations? Grass, being a diverse and hardy organism, helps maintain nutrients and moisture in the soil, maintains topsoil, and ensures plenty of other insects and mammals will eat, produce waste, and die, creating rich, usable soil. Added to that, grass has short and small roots. They are very minimalistic in their own resource usage. In short, grasslands are the perfect environment for trees to grow. Grasslands aren't climax vegetation because trees can take over grasslands within a decade or two and be a mature and healthy forest in several decades further. In grasslands around the world that are unattended and unaffected by humans, we can see the grasslands being converted to forests extremely fast. Grasslands are in a state of proxy fire climax. Stopping the seasonal burnings will allow for trees to be reintroduced. Grasslands are what happens when you constantly remove trees from an ecosystem and not a result of a natural apex organism dominating and propagating its own environment. It should make more sense now when I said that grasslands exist in the same climate types of other biomes because they are stripped versions of those biomes. In true biomes, we see an increase in complexity, especially within the climax organism. The opposite is true with grass. It has not evolved to be a grassland, if that makes sense. On the other hand, we have pines, which have evolved to be burned. In fact, many species of pines from around the world would go extinct if seasonal burnings are stopped for too long. They have evolved to rely on forest fires to replant their own seeds. By allowing themselves to be dry for long periods of time, they can prepare for the seasonal burning and preserve its resources for the next generation of pines. It's an incredible survival technique and one that is impossible to be some natural evolutionary adaptation. It's a deliberate response to tens and possibly hundreds of thousands of years of burnings. For some perspective, natural forest fires like those caused by lightning only account for 1 out of 10 forest fires. In fact, it is so rare that there are almost no recorded forest fires caused by lightning in the last few hundred years, which rules out an evolutionary adaptation over millions of years. There simply isn't a consistent fire-producing event aside from human-created fires. So ancient fire economies influenced the geography on a massive scale. The agricultural revolution furthered man's impact on forests, creating these false grassland climax vegetations. Taking all this into account, environmentalists trying to stop deforestation and save forests need only to do this, a somewhat reverse of the process. Instead of trying to plant seeds where major lumber deforestation is occurring, where the soil is poor and the ecosystem is suffering, plant trees where grasslands have been for hundreds of years, and recreate forests in a matter of decades. To repurpose forests that are being cut down in the long term, the healthiest option is to turn the deforested areas into grasslands in small sections at a time. Using fire can greatly enrich the soil. Allow portions to become grasslands before trying to plant trees. Instead of going from topsoil to tree, go from topsoil to grass to tree. It's a solution that just makes sense biologically. Part of the hesitation is that science and biologists think that grasslands are their own established biomes, and therefore if you tried to plant trees, the grass would take over. The truth is, trees have roots that go much deeper than grass roots, which allow them to reach nutrients inaccessible to grass. They don't really compete in that sense, and when you factor in mycorrhizal relationships, the only thing stopping forests from retaking grasslands is humans. It's almost as if grasslands have evolved to prepare for trees, or perhaps it's more accurate to say that trees have partnered or domesticated grass. But that's probably too humanistic a metaphor to apply to plants. The point is, humans have both intentionally and unintentionally burnt forests for hundreds of thousands of years, creating what appear to be grasslands, but what are in reality areas of treeless forests. I think that this is a good place to end the video, although the question of the origins of fire remains unanswered. Perhaps in a future video, since this is already long, I'll approach this subject again from a mythological angle, as opposed to anthropological and botanical ones. If you want to find an answer to something, committing yourself to a single field of study can be limiting to the point of gross misinterpretation, distorting how we see things from the past and ultimately how we view ourselves as a species and individually. Thanks for watching. Peace out.